Hi, I am Dr. Baby Shalini, Associate Professor, Department of ECE, Rohini College of Engineering and Technology. In this video lecture, we are going to see about various classifications of oscillators. So first, let's see what is oscillator. Any circuit which is used to generate a periodic voltage without an input AC signal is called an oscillator. So, an oscillator is a circuit which produces oscillations or waveforms without accepting any AC input. To generate the periodic voltage, the circuit is supplied energy from a DC source. So, in order to make the devices to operate, we need a supply voltage, and that is provided by a DC source. If the output voltage is a sine wave function of time, then the oscillator is called as a sinusoidal or harmonic oscillator. It is basically an amplifier circuit with positive feedback. Thus, the amplifier can be defined as a circuit which self-generating some waveforms such as sine, triangular, square, etc. It is also known as a converter, and it converts power from DC supply into AC power. So next is the classification of oscillators. So oscillators are mainly classified based on several conditions. So first let's see the classification according to the waveforms generated. So according to the waveforms generated by the oscillator, it is classified into two types: sinusoidal oscillators and relaxation oscillators. If an oscillator is producing either sinusoidal or cosine waveform, then it is called a sinusoidal oscillator. And in relaxation oscillator, other than sinusoidal waveforms produced by the oscillator are called as relaxation oscillators. And the figure shows various waveforms generated by the oscillator. Next, let's see the classification of oscillators based on fundamental mechanisms involved in the oscillators. So based on this, we can classify oscillators into two: the negative resistance oscillators and feedback oscillators. Negative resistance oscillators uses negative resistance of the amplifying device to neutralize the positive resistance of the oscillator. So as a result, we can get oscillations. And next is feedback oscillator, which uses positive feedback in the feedback amplifier to satisfy the Barkhausen criterion. Let's see that in the next video. And next is the classification of oscillators based on the frequency generated by it. So actually oscillators are the devices which provides or which generates waveforms. So the waveform consists of a time period. The reciprocal of that time period is called as the frequency. So based on the frequency generated by the oscillator, we can have 5 types of oscillators. They are audio frequency oscillator that produces waveforms up to 20 kHz, and radio frequency oscillators produces waveforms between the range of 20 kHz to 30 MHz. And very high frequency oscillator produces waveforms in the frequency range between 30 MHz to 300 MHz. And ultra high frequency oscillator produces waveforms from 300 MHz to 3 GHz. And finally, the microwave frequency oscillators, they produces waveforms above 3 GHz. And next is the classification based on the type of circuit used. So normally sinusoidal waveforms may be classified into two types: LC tuned oscillators and RC phase shift oscillators. The LC tuned oscillators consist of two circuit elements. They are inductors and capacitors. So based on this, it is given the name LC oscillator. And similarly, the next type is RC phase shift oscillator. So as the name indicates, RC oscillators consist of two circuit elements. They are resistor and capacitor. The most two commonly used types of oscillators in RC are Weinbridge oscillator and RC phase shift oscillator.